Good morning. Last class I introduced the subject. Today we are continuing with it. Today primarily we will on variables and data types, data sources, models, modeling, the definitions and the types, and principles of modeling. The principles of modeling in general applicable to any kind of models, but we are basically interested in statistical models. So as and when required, these principles you apply in the statistical modeling also. Let us see next.
So, let us see some of the slides now that I told you what is multivariate and what is this, it is discussed. Why should I use it? It is obvious question, and that why should I go for multivariate things if I can do by some other way, why multivariate. So, there are some key issues which basically will be known to you later on, that when we talk about multivariate, we talk about multiple variables, that is p cross 1, if p is the number of variables x 1, x 2 like your x p. Now, there is possibility that these variables are interrelated, there is correlation. One of the issue is correlation in between the variables. So, that means you may get a correlation matrix, or other way it is basically the covariance between the variables or covariance. By covariance, what I mean to say that if one variable vary, there is a possibility that in particular way some other variable will also vary, then there will be covariance, and standardized covariance is correlation. This issue will be discussed in the subsequent lectures. So, covariance, that will be a p cross p, that matrix will come. Okay. So, all those things. So, similarly the mean values for all those variables mu 1, mu 2 like mu p, these things will be there. Now, so my answer to your question is that why should I use it? Because no physical process or as such any other systems also which is characterized by multiple variables, they should be analyzed. Other way I can say their behavior should be analyzed taking into consideration of all the variables characterizing it, when these variables considered very important for the design, development or improvement of the system for which it is developed. And as it is obvious that there will be covariance or correlation between the variables. So, if I go for univariate analysis, we will lose substantial information about the behavior because of non inclusion of the covariance structure. So, we require to control this covariance structure, and in multivariate statistics covariance is a very big issue, and which will be in multivariate descriptive statistics I will be discussing all those covariance things. So, it is required, obviously it is required. For example, for this case like our this one steel washer, this case the steel washer, 3 variables are basically controlling its quality: inner diameter, outer diameter and thickness, and there is a chance that inner and outer diameter will be related and also the thickness. So, in that case the customer will not be able to apply it or fit it to its own situation if there is huge mismatch. Now, if I control individually inner, outer or diameter or thickness, then what will happen? The correlation structure will not be considered, and ultimately you will not be able to satisfy the customer. Okay. So, you will be using multivariate statistics or multivariate modeling when your system is complex in terms of number of variables. It may be ill conditions like this, the correlation covariance structure is intact. Okay. And in order to extract those correlate information, you want to extract the pattern from this data, that is why you will be using. Okay. So, how do I do it? It is through different models. So, these models will be described little later. Now, what is next? Next one example, here we are saying that a particular company operating maybe in a city market, and we want to see the organizational health of this company with respect to profit in rupees million, with respect to sales volume in rupees 100, absenteeism, machine breakdown and M ratio. Actually, this is created intentionally. First one is profit and sales volume. These are the organizational issue, that health. If you sell more, your profit may be more, and if your profit is more, you are healthy in financially. And another issue is absenteeism. If you are paying substantially, and if you are taking care the well-being of the employees, absenteeism will be less. And if you are maintaining the health of the process, here we are saying machine, your machine breakdown will be less. And if you are able to coordinate with customer as well as your supplier, and your M ratio, that marketing ratio, particularly if I say marketing ratio, it is related to the customer, and that will be high. So, if this is the case, and then we are basically observing from April, May, June, July, that 12 months data, and in some units you have measured, and this is nothing but a case of multivariate situation, where each of the row, like starting from 1, the first row, these values are talking about multivariate observations for month April, for similarly for second, these are multivariate observations. So, there are 12 multivariate observations. Okay. Now, people may be interested to know how profit varies over the months, then it will be univariate one. If you want to say that how sales volume vary over the month, it will be also univariate one. If you want to know absenteeism varies over the year, the months, that is also univariate like this. But if you are interested to see that how the profit and sales volume co-vary and their own variation, then you have to consider two variable, and then this will be a multivariate situation. Sometimes you may be interested to know that how the sales volume will be dependent on absenteeism, machine breakdown and marketing ratio, and then this will be a dependent model, and that is also a multivariate issue. So, this is in nutshell what I talk about multivariate observations. So, now we have discussed some of the things, some of the variables into consideration, and we have seen that we have assigned them some values, but where from those values are coming. For example, if I say that steel washer, the thickness, that may be the inner or the outer thickness. So, how it is known? So, you have used some measurement scale to measure this. If I want to say that maybe you have used vernier caliper to measure the outer diameter, you may be used vernier caliper to measure the inner diameter. So, you have used some instrument, and as well as there is a scale of measurement. In this case, this scale is basically length, which may be in terms of millimeter. So, you have to use some scale of measurement, and based on the scale used, whatever data you get, those data will be of different types. Okay. So, you see this slide here, the left side is we are talking about random variables, and right hand side we are talking about data types. I have explained you this random variable earlier. So, I will not spend much time here, but rather you must please understand one thing only, that in random variable there will be discrete and continuous random variable. By discrete random variable we mean to say that they will take the some counted count values like 0, 1, 2 or something like this, or January, February, March, something like this. Okay. So, and our continuous case, that profit absenteeism breakdown over M ratio here, what is that, any value is possible. So, please understand one thing here, sales volume are coming under your discrete because it is a countable one, but many countable such count values can also be considered continuous in many situations, but anyhow. So, there are two types. Now, your data types, I told you that what measurement scale you are using, based on these data types will be known, means the data will be having certain properties, because data is nothing but information. How much information is available in the data? Getting me? So, it all depends on what scale you have used to measure this data. So, based on that, there are 4 types of data. One is nominal data, ordinal data, interval data and ratio data. Let us discuss something about nominal data. By definition, it is provide identity to some items or things. If I say the month, the company, small company, the business, I have shown you that they want to know over the different months what is the status. Suppose the month is a variable starting from January to December, because it changes. So, then it is January and February, all those things nothing but they are the identity of the period of time, identity of a particular period. Suppose you just think of you are trying to know the some performance or status of the different departments of for example IIT. So, then if I say IIT, the department of chemistry, department of physics, department of mathematics, department of computer science, department of industrial engineering and management. So, all those things they are basically providing identity, but we sometimes require this type of data in our to include in our analysis. So, this is nothing but nominal data. Now, what is the problem with nominal data? Problem with nominal data is that there is huge computational limitations, because you cannot do any arithmetic operation. We cannot add department of chemistry plus department of physics like this. We cannot say department of chemistry is 1 and department of physics is 2, and accordingly we will add. We cannot subtract, we cannot multiply, we cannot make divisions also. So, this is the problem. Next data type is your ordinal data type. What is ordinal data type? Suppose you just see that you have traveled in flight several times, maybe, or train or some other place, or you have gone to restaurants and where you have taken food, and you might have seen that you are giving a feedback form. They are asking that please rate the in case of hotel, that food quality, service quality, room quality, all those things in terms of not satisfactory or totally unsatisfying to extremely satisfying. This type of scale you have used. For example, for the food case, you can say okay, taste wise it is very good or something like this. So, this type of ordering, when ordering is there, this is called ordinal data. Okay. So, what it does, it basically provide some order or rank to some items or things. Example, service quality, it is low, medium or good, and computational limitations, here also we cannot do any arithmetic operations like your addition, subtraction, multiplication and division, you cannot do. Then what way it is better than our nominal data? It is better than nominal data because here you are getting a order, a rank you are getting. If I say the performance, my student performance is low, average, very good, excellent like this, the person who is getting excellent, he is definitely better than the person or the student who got very good. So, I have a ranking scheme here, I mean ranking ability with this data. Okay. So, ordinal data is rich compared to nominal data. Next data type I said that interval data. What is interval data? It is basically well understood if we take this example. Here temperature, you are measuring using two scales, one is Celsius, another one is Fahrenheit. In developing these two scales, for example Fahrenheit scale as well as your Celsius scale, the reference point is taken at two different places, means locations, it is not the same, you are getting me. So, and if you see the horizontal lines here, you see that 0 degree centigrade, 20 degree centigrade and 100 degree centigrade, then the corresponding Fahrenheit here range is 32, 70 and 212 Fahrenheit, fantastic. So, there is a range, when if I say the difference from 100 to 0 degree, you are getting this range, here also the 212 to 32, the corresponding range is this. So, that means whether we measure in Celsius using Celsius scale or Fahrenheit scales, we will be getting the equal range. Now, what will happen? Suppose I measured a temperature today's day temperature is 20 degree centigrade, tomorrow 30 degree and maybe day after tomorrow again 21 degree. Then if I want to do the averaging, I can add them and then divided by 3, that 3 days average I will get. If I do the same thing in Fahrenheit also, it is possible, I can do that similar thing I can do. But what will happen, suppose I want to say that what is the how many times temperature of today is compared to the tomorrow's yesterday's temperature, then if I use Celsius scale and if I divide, suppose if 22 by 20 and then here it will be maybe 70 and some other things, then you will find out that they are not matching. So, that means interval scale is some scale where you will get a interval data, range data, and they are all having all types of continuous properties, except and they can do 3 arithmetic operations very easily, addition, subtraction and multiplication. But when you do division, you will find out that when you changes the scale, ultimately what will happen, you will find that they are not matching. So, in interval data you cannot go for division, interval data division not possible. All other arithmetic operations possible. Let us go to the next our slide, that is we are talking about ratio data. Ratio data is something where there is absolute 0 in the scale of measurement, this is 0. If I move towards right, suppose x amount, and towards left also x amount, then the difference, this difference is same. If I go for y also, this side also y also, that is the same. So, that means if you go in to the left it is negative, this side it is positive, but there is absolute 0 in between. Okay. So, this 0 is the reference point, not in terms of that Fahrenheit and centigrade scale, that where is the two different reference point. So, definition is contains absolute 0, highest form of data, sorry. So, ratio data is contains absolute 0, highest form of data, example absenteeism breakdown hours what I have shown earlier, and computational limitation in all arithmetic operations are possible here. Okay. So, now if I go by the order of information available, then definitely your first one is, if it is nominal, then followed by ordinal, then your interval, then your ratio, then definitely in order of increasing information, this is the case. My base data is this, next best is this, next best is this, next, and this is the lowest form of information data. Okay. So, you know that different data types. Now, you know that as you will be applying multivariate statistical modeling, you must require collect data. So, you require to know the data sources. So, primary data collected from the source where it is generated. For example, in the case of steel washers example, if you collect data where from the production shop, just going there collecting data, that is what is known as primary data. Okay, suppose you want to see the behavior of the animals in the jungle, go and observe and then accordingly note down, and that will be your primary data. Okay. So, for the production, that CTCAN, that example, the profit map and sales volume case, that is also primary data, so long you are collecting from the source. What is secondary data? Secondary data stored in a repository or collected by someone else. Getting me? So, you are not collecting, it is already there. We have different sources. For example, you may get the financial data from some sources, and suppose company is maintaining records of their production, and suppose the maintenance or the health of machines or many things. Okay. So, you have not collected. So, company has stored and you have gone there and collected these things, or it is better that in a literature you are studying something in your own area and you found that a paper is there where some data is given. So, this type of data is secondary, but secondary data must be authentic in the sense that reference of the data is available, authored references are there. This is authored literature data, but this is definitely as it is done by somebody else, it is not primary. There you have to rely on the authenticity of the data collected by somebody else. Then tertiary data, which is basically a common knowledge type of things. Okay, suppose in Wikipedia you will find many things are there. Actually, when in terms of modeling, when you start with a subject area, you start with this, that when your knowledge is not that much clear, and you will start with the tertiary sources, and then slowly you go to secondary source, and then finally when you do actual work, you will go for the primary data sources. I told you earlier what is model. Let me repeat this again, that model mimics reality. If you develop a model that without considering the reality, real thing, you are not doing the justice. So, model mimics reality. So, it should be it should have real applications, that is what is the meaning. For example, suppose you think of a car which is produced by suppose any automobile company, and they develop these things. What I mean to say, they develop a model, simulation model in computer first, before going for developing the car one after another, or manufacturing the car in the manufacturing shop. What there must be some simulation model, okay, and means how the car will work. So, that type of things are known as that means it is in terms of the reality, the car is the real thing. So, you are modeling something. So, the spring balance example also, that the mathematics is related to the elastic behavior of that is the reality. Okay. In statistical sense, when you talk about the how cells volume is dependent on other things like this, your absenteeism, M ratio, all those things, that also going to talk about the reality. So, actually in statistical sense, a model talks about explain the regularity of a phenomena. Okay. In Hooke's law, the regularity is so long it is within the elastic limit, when the load is released it will come back to the original shape, that is the regularity. In case of our statistical model building, we talk about data, and data is nothing but equal to this is pattern plus error. This pattern is the regularity or systematic component. Okay, so we must know what is our problem, and accordingly what data you have collected, and you want to extract pattern from this data. Okay. In case of prediction model, suppose you want to predict some y value, then with respect to some x values, and then you will find out there is some linear combination of variables, that is x beta, and then plus error will be there. This is my regularity or pattern, this one is the error. Okay. Now, when you repeat similar development under different situations, then what will happen if it performs well under the different situation for which it is developed, then one day we may say it is a law or a theory like Hooke's law, or Hooke's law is this one, the elasticity theory. Okay. So, we all know that Newton's laws of motions, and we all know that Dalton's atomic theory, and many other things, that these are not that one day everything is developed and people accept it. It basically developed, tested and verified, validated after several years, and then other scientists, that is the researchers, they accepted the fact, and then it was applied to different situations and found that it is working. Okay. I told you modeling also, process of building a model, physical, mathematical and statistical, this is I already explained to you. I hope that you got a glimpse of actually the purpose of applied multivariate statistical modeling. Actually, we want to develop empirical model. Okay. Those empirical models, these are all data based in the sense data driven. You have data and you are going for model, you are building model, and to find out the regularity of the data or the pattern of the data, and so that you will be able to describe the relationships of the population or the behavior of the population or system in consideration. You will be able to establish the strength of the relationship. You will be able to predict something. You may be interested to prescribe something also. But when you talk about statistical modeling, usually this is the description and prediction part is description, explanation and prediction. Okay, these three things comes into consideration. So, slowly you will be knowing different types of statistical models altogether, and you will be tempted to develop different models also based on the data whatever available to you. But before going for modeling or applying any statistical techniques, what is happening, what we want to say that you have to have some principles in your mind before going for this. Here I have just jotted down some of the principles which I have taken from a book by on operation research by Ravindranath et al. You just see what is said Do not build a complicated model when a simple one will suffice. For example, suppose if I know the mean value of different lots of steel over mean value of a particular characteristic, for example, the inner diameter of different your lots produced. Okay. And if that suffices my purpose, go for mean, or at max you may require the standard deviation and mean of the inner diameter produced by the different processes A, B, C, as I have told you. So, there you may you do not go for maybe okay that covariant structure, many other things, it may not be needed. So, you do not go. If it is needed, you go for. Beware of modeling of the problem to fit the technique. Many a times I have seen in my case, there is one model which we will be discussing later on, known as structural equation modeling. People are using structural equation everywhere, where a simple regression model can be okay, but people are interested to fit the structural equation model. So, please be a little bit of cautious all those things, that model is for problem solving and model comes from the problem, not to fit a statistical technique. The design phase of modeling must be conducted rigorously, and it will be discussed later what do we mean by design phase coming under study design. Model should be verified prior to validation. Verification means, suppose when you collect data, you split the data into two halves, one for your training, another for test, or other way I can say one set for model building, another set for verification. And validation basically talks about when you take some new data again and you find it is working, that is validation. A model should never taken be too literally. Many times what I have found that it is the model okay, there are many variables, statistics is taken in very loose sense. Okay, there are many variables, let us find whether relationship is there or not. This type of, or whatever variable is there, let us find that relationship without considering the purpose. Then a model should neither be praised to do nor criticized for failing to do that for which it was never intended. For example, you are interested to see the relationship between several variables of a particular population. Now, later on you want to see that how I want to predict something. See, you developed a model to see the pattern and strength of relationship, not to predict. So, how can your model will predict which was not intended for? So, that is another issue. So, if it fails to do prediction when it was just to understand the covariant structure, then we should not criticize for this, or we should not praise the model to do it. Beware of overselling a model. Many a times we basically make sure of I can say recommendation based on a model, and many of the things are basically from common sense, and so that type of selling is prohibited. Some primary benefits of modeling are associated with the process of developing the model. So, as all of you are basically learning multivariate statistics, multivariate modeling. So, do not think that always you will be doing something great with this type of modeling, you are learning. So, the learning process, when you develop something, you know the physics of the problem, maybe you know the process through which data is generated, you know how the data to be captured, how the data to be analyzed, what techniques is applicable when. So, this is entire gamut. This gamut of process is very important. So, many benefits you accrue out of it. A model cannot be any better than the information that goes into it. So, you cannot say that you are using nominal data and you will be basically talking about a model of regression where y variable is nominal. So, you have to go for some other type of model, maybe your logistic regression. So, the information the quality of information what is fed into that model, that is more important, because if the input is not good, output also you should not expect good. So, model cannot replace decision maker. Getting me? You cannot think that your model is superior than you. The decision maker, the analyst who is having the system knowledge, the domain expert. So, they are more important people. So, whatever you develop, whatever you do, whatever for what purpose you are developing all those things, so that is in your brain, in the group who are working, they know better than any model. So, in this case what I want to say that you please take all those issues what I have discussed now, the principles particularly into seriously, and accordingly develop the model. And today it is up to this.